Yeah, but Mustafi, but I don't see the option to broadcast.
No, I already did it.
Oh, I did it. Okay.
But I see that you're showing pre-course survey, how to complete
Yeah. Okay.
lab
All right.
exercise.
All right. Thank you. Thank you. Yeah, that's fine. You can go. Yeah, if you need to go, you can leave now. So I will
Sorry.
start the recording.
Okay.
All right. Thank you.
This is okay.
All right. Okay. So I'm going to start recording. So then, alhamdulillah, salatu wassalamu Rabbi shali sadri wasli amri wahlul for holy. Okay. So I started recording. All right. Okay. So I will not most likely be watching this. All right. So we'll continue from yesterday. Slide string also. Okay. All right. So this is the course. If you remember. Oops. Sorry. It was in the student view. So this is a course called AWS Academy Machine Learning, and I received a few requests to add. So if you want to be added to this course, please email me your email address. You can email me on my email, and I'm note down my email, Muhammad Sabri 01@gmail.com, and then I will add you to the to this course, AWS Academy. You will receive an invitation email inviting you to join this course number ending at 87151. And then you just have to accept the invitation, and then you can create a password, and an account will be created for you. And then you can see what I am showing you on the screen. So then you will see this icon on the AWS Academy dashboard. You will not see so many icons, okay? So because you only will be have one course, and you will not see so many things either. What you will see will be like as a student, you will be seeing only four options like this. And we are only deal with modules because I'm not watching the discussions or I'm not grading anything. So I'll just give you the access so you can go through the modules. Okay, so there are like 8 modules in this course. We covered 2 modules yesterday, and then I'm planning to start the module number 3 today. But before I do that, I just want to introduce a little bit about Impact Tech because I'm an educator or an instructor for Impact Tech. Okay, so let me bring Impact Tech presentation. So Impact Tech is a non-profit organization based in Fairfax, Virginia. Um, this is their website, impacttech.org. And if you need more information, you can email them in info@impacttech.org, or you can call them. So please note down this number or email address. If you are interested in getting IT, even for high school, I have several high school students, and to be honest, actually those high school students were more motivated and hardworking and more interested than the adults or people who are coming from other profession. They want to get a better paying job. So this Impact Tech actually is a non-profit organization, and it is designed, or its purpose is to serve the underserved communities like immigrants and people who just came to this country, or people who are working odd jobs and they want to get into IT. But I found that the high school students are the best students basically. Okay, so it's a 501(c)(3 non-profit IT training and employment organization in Manassas. I mean, they're headquartered in Manassas, but actually now they also have a main in Fairfax to empower undeserved or underserved communities by providing practical information technology training and employment opportunities. Okay. And then they also have scholarships and grants, and I mean, I don't want to spend too much time over here, so please contact them. at any call them or email them for more information, and then they can talk about what scholarships and grants from from the state government and counties. They have programs, and all our courses are very hands-on practical training and prepare for the certification exams also. And we have both in-person and online classes, and they also help for job placement and resume help. And so they have, and they also have some free classes retakes. So once you pay for one class, you can retake that class whenever it's offered again for free. And then you have access to class recordings also. They have payment plans, refund policy, and then they also, help you with extra help and tutoring and group studies. Okay, so this is just some their marketing stuff that AWS Cloud professional salary is the highest and usually no degree required. So in IT, basically degree is a waste of money and time, to be honest. Um, Even the federal government and state government, they have all already waived the degree requirements, except for the management position, But for hands-on technical position, they really don't require the degree. So you can just find a job and then experience, and then you can get the degree while you're working. They will pay for it. Most companies will pay for your degree also, and then that way you can start early, and then they are just looking for people who can do the work. Okay, so and I'm also covering the AWS cloud. So the machine learning and professional, and their salary actually are even higher. They can go up to if you I don't know if you read the news that last year there was a strike by the script writers, for the movies and TV shows. So those screenwriters, they stage a strike. So because they were afraid of the chat GPT and AI, invasion basically into their, and they thought that they will lose their jobs. So instead of that, what Netflix did actually, that while their writers were striking, and then so they just say, okay, we don't need you guys, but they advertise a position for an AI machine learning product manager with, of course, enough experience and everything. But they advertised his salary as almost, I think, $1 million, 900K or something, close to $1 million a year. And so it was like basically a slap on the face that, but this is the thing where things are going. That unless you know the AI machine learning things, normal jobs will be very difficult, become very very less. And because AI, so you need to learn about AI and machine learning. That's a must for future. So Impact Tech has a different programs like for cybersecurity, cloud, networking, data analytics. So I teach data analytics, machine learning, and also cloud. But they also have other programs, IT fundamentals for non-technical people, business administration, business analyst position. All right. So what they do an assessment, that where you stand right now, and then they help you guide you in selecting one of those paths, and the training programs, and then hands-on training, certification exam, job placement, and this is what they do basically. Okay, so to break into IT, there are two main paths in IT: technical, non-technical. So technical, like what you are doing is technical. Non-technical would be like business analyst, but more and more jobs are going toward a technical role. So these are all technical. So IT support, IT beginners, for they go for CompTIA A plus certification or Network Plus or ITIL, network system admin, CCNA, or cyber security. Cyber security is also very hot these days, and then cloud is even hotter. Programming, as I mentioned yesterday, that programming is hot, but only for the experience and top notch. For normal entry level, it's very difficult to get into programming now because of the AI machine learning tools, like we will talk about today also. All right, so they have this non-technical path for the data analysts or project managers, and Salesforce admin. So these are basically considered non-technical. But the more technical you are, the better you will be, and you increase your chances of getting job also. And then Impact Tech also has a lot of partners. As I told you, we are AWS partner also. That's why I'm AWS accredited educator through Impact Tech. But we also partner with the CompTIA, Splunk, Microsoft, and a lot of other. And we are also certified by SHEV to open the State Council of Higher Education for Virginia. So, all right. And then these are the partners and which worked with to find the jobs. And these are scholarship. For example, the Workforce Innovation Opportunity Act. It provides some for retraining for the people who lost job, and then to get training in IT. So they pay for the training. And then there are a lot of others like Montgomery County has this work source. Prince William County also has some programs. Darul Hijra also sponsors this mosque in Falls Church. They also offer some scholarship for to get people into IT. All right. So again, this is the phone number. You can call them, talk to the support or the info. You can also email at info or information at it's the same thing. Both of them are fine. Info at impacttech.org or information at impacttech.org. And this is our current location, 8550 Lee Highway, Suite 725. So, so this is a short introduction to Impact Tech for whom I teach this course. All right, any questions before we start on our NLP, natural language processing? So yesterday we covered the basic introduction. We covered what is NLP, and then we also did a common NLP task, walkthrough of an NLP problem, and then we also had a very quick walk through a lab. So the best thing about these courses are that all the slides which you will be seeing and more, they are all under the student guides. For each module, they have the student guide where you have the slides, which I will be presenting today and did yesterday. And then main thing is the lab, because this gives you an account. It creates you an account when you start a lab. At that moment, it creates an account and gives you access to resources in AWS, so you don't have to worry about money, because if you create an AWS account, you'll have to give your credit card information, because even though they say that it's for 1 year it's free, but not everything is free. So you have to be very careful what is to only use the free sources or free resources. If you don't, by mistake or whatever, you can accrue some charges. And that's why they take your credit card information, that at the end of the month, if you accrue any charges, they will charge your credit card. So that's why people are wary of opening an account, and it's risky, especially if you're new. And even for experienced people, it's very easy to forget something, and then your charges can accrue. So that's why this is an ideal situation, that you join a course, and then you don't have to worry about the paying or charges being accumulated, because the labs are short lived, the maximum like 8 hours, but usually they are 2 3 hour long, and they are free, and you can do them as many time as you want. Okay, so today we'll start from this module 3 quickly. Module 3 is what is called let me start the presentation for module 3, and then I don't think that we will have a time for the labs today, because even module 3 has like 3 labs. Okay, 3.1, 3.2, 3.3. And then module 4 has one lab, module 5 has 2 labs, module 6 has 3 labs, module 7 has a lab, and module 8 it doesn't have a lab. It's just about generative AI, which is like chat GPT kind of thing. And then if you want, I can give you access courtesy of Impact Tech, because if you take the course, of course you'll have to pay money, but because of the collaboration with the hackathon, with the this ITP UF organization, so I'm willing to add you and then give you access to this course. It's about 24 to 30 hour course. And if you take this course from Amazon, they will charge you like about, I think, $1,500 or $2,000 per day. And this is about 3-day course. Okay, all right. So the student guide, if you click on the student guide, it will show you the slides, which I will be showing you in PowerPoint. So as an instructor, of course, I get but you can see the slides here. Okay. So for example, this module has 67 slides, and then you can move through the slides from here, looking, going through this one. But I will be doing the presentation through their PowerPoint slides, which is like this. So this is some repetition from yesterday, but it's a good overview. So I will go over it quickly. So again, the text processing overview. So what happened in text processing stages that there are several steps, they call stages in text processing. So you will be doing the same thing if you decide to use this for your hackathon idea. You of course you will have to do the same thing. So what you do, you extract the text from data sources either through the websites by what we call web scraping, or you convert some documents, you scan them, or on the internet or whatever, download them, and then you convert them into text, or and you do it automated because manually is a very tedious job. Then so that's the first step, extract. Then you load that data into a data store, and then you write some code either for loading, or there are AWS services like AWS Glue, which automatically can what is it called, a crawling. It creates a crawler, which is actually a software program in the backend. It uses Java, but you don't have to worry about it. You don't have to write any code. It automatically creates a program which can crawl through either your website or your document and extract the information. And then they also have a service called Data Wrangler, which can handle the data transformations. And then you transform and do the feature engineering to, like processing, data pre-processing, and tokenization, and so on and so forth. So this is a very common technique. It's called this is ELT, extract, load, and transform. Before that, you have probably heard of ETL if you are in IT. ETL is extract. So that is basically what happened, that is for the data warehousing, ETL, that you have your transaction processing systems, and it's called online transaction, OLTP. Like for example, they use the databases. So at the end of the day or some fixed time, there these script runs, extracts the data from their transaction systems, and then it transforms it according to the data warehousing, data analytics requirements, and then loads them into what we call a data warehouse or a data lake. So that process is called ETL. Now over here, now they change it. This instead of extract, transform, and then loading, is now extract, load it into some data store, and then transform it there. Okay, so that's called ELT. Now, what kind of that text can be extracted from the unstructured data, from the raw text, the words or sentences, or the whole paragraphs or the whole articles, whole books. Image data, so it can extract data from images also, and that's called unstructured data. Then there's structured data, which is coming from usually some your databases. This is your from online transaction systems or some databases. Is called tabular. Usually is stored in a tabular form. So for example, banking records or employment records, all these inventory records, all the systems so far before the cloud, actually, most of the data is stored in structured in the databases. Okay. And then read the data and structure from the forms also and convert them into structured data. So AWS Glue, as I mentioned, is a service. It's an AWS service that provides automation for your ETL, extract, transform, and load process, or it crawlers. So you have a data source, could be anywhere. It could be website, or it could be a database. So you create a crawler, and using this AWS Glue, it crawls. It automatically discovers the metadata. What is metadata? Metadata is the data about data, meaning that you have a database. So data is stored in the database, and you have some information about that data, that table, that what are the column names, what are their types, how long, things like that. This is called metadata. It's data about data. So the crawler discovers the metadata for your data sources and then stores it in a data catalog. It's called AWS Glue Data Catalog. Okay, so it's also on the cloud, of course. And then the transform script can be created by Glue or a user and after to extract the data and then load it into your wherever you want to load it. And you can schedule and also for this crawler so that it can at a fixed time every day, every week, every month, whatever your frequency is, it can automatically go and get the latest data. Okay, or you can run the transformation script on demand or as schedule, whatever you want. Okay, so these are some use cases where you would like to consider using the AWS Glue service. For example, DevOps pipelines. Now, these are advanced IT concepts. So if you don't know about them, that's okay. You don't have to worry about that. This is a development and operations. Now they also call DevSecOps, development, security, and operations. So you have stages of the process. So that's why they call it a pipeline. For threat detection, it can crawl through your data and see if there are some anomalies or there are some problems. Then data lake extraction. So data lake is a concept came with the AWS or a cloud actually, but AWS started the term data lake. So what happened, as I mentioned, that you have databases, right? For example, over here, you have the data sources, databases, and then when you extract the data from there through ETL process, you store it usually in a data warehouse, the target. But now in cloud, instead of a warehouse, because for a warehouse, you need to do some transformation. That takes a lot of processing. So instead of that, what we do nowadays is that's why we just extract it and load it, like over here, extract it and load it into a data lake. So data lake is just think of a lake. A lake is basically is a water body of water. When the snow on the mountain tops is melts, the water runs down the mountains, right? And it accumulates in a body somewhere which we call a lake. The same thing over here, that our data is coming from different sources, structured, unstructured, even semi-structured. There's also a middle way which we call semi-structured data. Okay, so all those data from data sources is come into a data store which we call data lake, meaning without any kind of transformation, nothing, just whatever data you do, because you don't want to mess with the original data. So you just copy the data into a data lake. Okay, and so that's also a good use case for this service called AWS Glue, and also the migration of older data to the cloud. So from your on what we call on-prem or on-premises servers. So a lot of companies have data, and even you guys also have data in your laptops and in your local drives, right? Flash drives and things like that. I think, probably hundreds of them. Um, CDs and all that. So we can migrate that older data into the cloud. Okay, so for that one, also the AWS Glue is a good service. All right, then they have this called Data Brew. It's a service within the AWS Glue. You can visually explore the data. So the Data Brew actually can show you data visually, profile the data to highlight the patterns, detect anomalies, meaning that which is outside the pattern, which is something we are not expecting. That's called anomaly. Clean and normalize the data without writing any code, just everything visually. Click, drag and drop, save and reuse the transformation on new data. And then data lakes usually are, the service which stores data in AWS is called S3. S3 stands for Simple Storage Service, SSS. So in Amazon, in AWS terminology, instead of writing SSS, they write it S3, meaning three S's, Simple Storage Service. So S3 is the basic storage for, AWS has some other also type of storage, but this is the most common and easiest to use and most commonly used storage and cheapest also to store your data. So the AWS Glue Data Brew service can, you can visualize the data, You can highlight the patterns, you can detect anomalies, you can clean and normalize the data without writing any code, and then you can save it on a S3 bucket. That's why that icon is a bucket. It's called S3 bucket. It's like a folder. AWS calls it buckets. Bucket, okay? This is AWS terminology. And then it gives you a data profile summary. For example, it says that I found 20,000 rows of data, 6 columns, and then these are data types. That there were one Boolean data. One column was Boolean. Boolean means it can only be true or false, one or zero. Only two values. It's called Boolean. Then a double is basically has the precision with the decimal point and numerical data with the decimal point and up to 16, 15, 16 decimal places. Then there are two columns like that. One column is integer only, so no decimal point. And then two columns contain string data, alphanumeric data. Okay. And then it gives you some summary like missing cells that, in 20,000 times 6 will be 120,000. So out of 120,000, 119,990 rows have valid, meaning they have data. 10 rows, which is less than 1%, are missing values. Okay. And 10 cells, sorry, not rows, cells, 10 cells. Okay, so because 6 times 20,000 is 120,000, out of 120,000 cells of data, it found 119,990 valids, with meaning that data contains data, and only 10 cells are missing data. And then it also gives you some duplicate that there were 19,972 valid rows, out of which 28 were duplicated. Okay, so this kind of summary is called data profile. Then this also gives you what we call correlation. Now this is a statistical concept, so hopefully you guys have taken a basic statistical course in your high school. It's very important. If you want to go into machine learning, artificial intelligence, you have to know some statistics. The more you know, the better it is. So there's a concept called correlation, and has a correlation coefficient which we define as lowercase r, which defines how closely two variables are related, meaning that this is a time and this is, for example, another column called log underscore votes or is positive. So how this variable time is correlated with this, meaning that if it goes up, this also goes up. It goes down, this also goes down, or opposite. It goes up, it goes down, it goes down, it goes up. So those are called correlations. So negative correlation means opposite, and if the time goes as the time passes, this thing is going down. Okay. So zero means there's no relationship, and it will always be between +1 and -1. Okay, so it cannot be more than 1 or it cannot be less than -1. So this data group will automatically show you a correlation coefficient metric. It's called a correlation matrix. Okay, that all the columns, how they relate to each other. Okay, and then it will give you some more data, some column statistics, distribution, data quality, inside, and so on and so forth. Like this, out of these 6 columns, it's showing you some statistics. And then you can create projects, and then you can do, like, for example, some predefined column action, like format the column, clean some data inside those columns, extract data, deal with the missing values. If they are words, you can tokenize them, and you can do some categorical mapping. Now these are statistical. This categorical mapping is a statistical technique. So I want to spend time on that right now. I think it will coming up, and then you will understand better with example. Okay, so what is tokenization is very important, especially for you guys for NLP. Tokenization is the basic data processing step. So what you do before you tokenize, meaning that you create tokens for words. What are the words which you really want? So first you remove the most commonly occurring words. These are helper words. They really don't contribute anything about your NLP project, so you remove them. And then you expand the contractions and you do the stemming, the root cause and things like that. So remove word, you can use the default dictionary, or you can have your own custom stop words which you don't want based on your requirements. Expands corrected words so that don't becomes do not. That's called expansion. Is opposite to contractions. Okay, so instead of shortened form, this contracted form of don't, it can change it to do not. And stemming is the basically splitting text into smaller units or tokens, such as individual lowercase words or term. Before that, it also normalizes the words to lowercase usually. Okay. Then you can create recipes, because they call it data brew. So you can have a recipe, which basically nothing but a list of steps, because you remember this is automated, right? But it's generating the code behind the scene. So so it creates what the script is called a recipe. So for example, it created three scripts for you. Number one, change format of review text to lowercase, normalization. Remove the special characters, white spaces, and then tokenize that column. Review text. Review text is the name of a column. If you want to see it over here, review text is the name of a column, the first column, okay, which we also saw in the lab yesterday. And then you can run the recipe jobs, schedule it, and then you can update the data, and you can extract it from your data lake or storage S3, for your project, and then you create a job for that to transform, do whatever your project requires. So this, because one set of data can be used in multiple projects, so but each one will handle it differently. And then more powerful data manipulation is called data wrangling. So AWS has a service called SageMaker, which is basically a Python. Actually, it's a Jupyter Lab notebook, which we also saw yesterday in the lab. It has another service called Data Wrangler, which is part of the SageMaker Studio. SageMaker. So Amazon did actually, they made, and they took the Jupyter Lab notebooks, and they converted them, and because it's open source project, so they took it and then they modified it and adapted for their own purpose, and they call it SageMaker. And then they converted it into basically an IDE, integrated development environment, for full-fledged development of artificial intelligence, machine learning, NLP projects, and they call it Studio, SageMaker Studio. So in SageMaker Studio, there's an option, or a very powerful um, companion called Data Wrangler, which is used to create for data preparation and feature engineering flows. Okay, this is the most time consuming for a data scientist or machine learning engineer. 80% to 90% of their time is spent in manipulating data, because data is a big mess. It's coming from different sources, and it's usually it's not the way you want it. So you have to do really wrangle with it, wrestle with it. Wrangling is another word for wrestling, basically. Same thing. So you have to manipulate, do a lot of transformations, or wrestle or wrangle with the data to conform it to your format which you want for your algorithms. Okay, and then you can import data from other services like from S3 buckets storage. Amazon Athena is another SQL service which can automatically query data in place, meaning that you don't have to extract the data from some other sources and bring it into your own memory or space, and then no. So that's why Athena is a very efficient service which runs the SQL queries. And then Amazon Redshift is a service on AWS for their data warehouse. It's a very powerful, very powerful database service, specifically optimized for huge data warehouses. So these are all three. This is a storage service, S3 in Amazon or AWS, because these are all before Amazon was using them. And then, they saw the utility of them. So that's why they thought about, marketing them as on the cloud. So that's why you see the name Amazon before them, because Amazon was using them before, it started the AWS, which is Amazon Web Services. And it only started in 2006. So it's about 18 years ago. But they were using these before that for their internal purpose. And then they saw the utility, that how powerful they are. That's how Amazon became a $1 trillion company. So that's why they decided to market it and then start the cloud and then sell it as a. So that's why will see, even though they are part of AWS, but they still keep the word Amazon. So Amazon S3 is the simplest storage service for storing data. Amazon Athena is an in-place SQL query service which can query data in place. You don't have to get the data into your database. And then Redshift is a data warehouse, very powerful, very optimized for data analytics and warehousing. Then you can create a data flow to complete the data prep steps. You can estimate the machine learning accuracy. You can transform data. You can vectorize it, build visualizations, export to notebooks like in SageMaker, Python script, SageMaker pipelines. So it's a very powerful environment. All right. Okay. So this is what I have been talking about in this section one for last 20 minutes. 20 plus minutes. Getting text is the first step in the ETL process or ELT, whatever order you want to do it in. Web scraping and extracting from data stores are two common ways to get data, either getting it from the websites or extract from some other databases or data stores. Because when you see database, usually it's a relational database, a structured data. So that's why they call the term data store. And data store usually is in memory. Database has a whole engine behind it, and it's a whole complex system. And the tools which AWS provides you are like these: Amazon Textract, which can extract the text from images or videos; Python libraries; AWS Glue Service; AWS Glue Data Glue Service; and Amazon SageMaker Data Wrangler. All right, so the first thing is the processing and getting the text for processing text, for NLP. So you can automate the data capture for your NLP applications, for example, marketing analysis, hiring, news analysis, or in your case, whatever, for Dava that you will have to extract the data from some websites, social media or websites or some, feeds. So you will have to use some Python libraries. Beautiful Soup is a library in Python for text parsing. Parsing means that you read, for example, when you're reading a sentence in English, you are basically your brain is trained, throughout your school years. That's what they taught you how to read and comprehend. So that comprehension is in computer terminology is called parsing. So that text parsing tools for hypertext markup language HTML, which makes beautiful pages on the websites, and also XML, extensible markup language, which is the parent of HTML actually. HTML is a subset or a child of XML. Um, and this is also called semi-structured data because XML is a language and HTML also is subset of it. But these are languages which a human being can also understand with some practice, of course, and some training and some effort. It's not that easy. It's more difficult than an English language. But a human being can read it because they are basically written in simple text, but they have some what they call tags which mark them up. That's why it's called markup language. Okay, so those tags make these beautiful, like text into convert into beautiful and other some other things, nice looking text. So XML is also can be used to some that's why it's called semi-structured data. When you have XML and then the other now the but XML is requires a lot of training and effort and it has a very steep learning curve. Easier thing nowadays we use is called either JSON format, JavaScript Object Notation, JSON, JSON format, or even simpler than that. JSON format came from JavaScript language. Okay, but that's also has a lot of extra characters. You have a lot of curly braces, square brackets, commas, colons, single quote, double quote, and things like that. So that also can become very cumbersome to read for humans. So the latest is what we call YAML, YAML, yet another markup language. So YAML language is much simpler than JSON, and its code is so its script is very easy, much easier to read than JSON or XML. These are called semi-structured data. Okay, So beautiful soup can be used to parse a text out of the HTML or XML, and then they have other libraries to get extract the text from JSON format and YAML format. And then Scrapy is another library in Python, which is a set of tools for more complex projects. So that's Scrapy. So for example, in web scraping, what you do, let's say that let's say you want to extract some key information such as stock pricing. So I did a project, for my brother also, because my brother, wrote a program where he needs to read the data from some articles and some websites. So, so this is, for example, a stock pricing, from a web page. So now the information which we need, is included with a lot of other extra information here. So we have to use some text extraction tools and some basic HTML knowledge, because this beautiful, way actually is, if you look at the code behind the scene, it's an HTML page. It's a web page. So the code is written using HTML. So this is an HTML table, and these are some HTML, sections. So we have to understand a little bit of basic HTML, and then we can create a script to extract the information that we need. And then we also store that information in a format that is more appropriate for solving our business problem. So for example, I need this information. For example, I need that what we call ticker symbol of the stock code. We call it ticker symbol. Then the open price for the day, closing price, and the volume of shares for that day. Okay, so somewhere will be, so this is a ticker again here, any, and then closing price, the change during the day, after hours price, and then summary. So this is we need to identify the pieces of information and then only extract that information from this web page and store it somewhere else where we can handle it. This is called web scraping. So you can use Amazon Textract service, which retrieves data directly out of scanned documents. So not from the website, but from the PDF files and the other images. So it can, you give it a document, and then document can contain multiple pages, and each page can contain multiple lines and tables, or what we call key value set. Okay, so it can extract data from pages of text, forms. You can have a lot of form data, like doctor's office, or a survey form and things like that. Then from the form, it retrieves as key value pairs, because form has a question, or a key, and then it will have an answer, which is the value. So that's why it's called key value sets or pairs. You can extract from tables of data as a columnar data, and then you can have some selection element, check boxes, option buttons, retrieve from forms and tables. So text rect service can automatically read all these kind of different things from the scanned documents, PDF files, for example. And then you load the text data which you have extracted into a processing pipeline. So the Amazon TextRect can automate text extraction with the AWS CLI interface, command line interface, which is, you do the command on the, for development, or you can do the for the software programming application programming interface API calls. Okay, so for example, this is a document. It can analyze it. That you can see it identify this key value pairs. This is a column name, full name, column, and then the answer, phone number, and then the value, home address, and there's some value, and then mailing address, and some value. So it can automatically extract and create, and show you in like this nice format that this text rect service can automatically extract data from there, and then it can identify these things. All right, so some tools we talk about, Beautiful Soup and Scrapy are the Python libraries, and then Amazon TextRect is you don't need to do the programming. It's almost this is called low code or no code system. It can extract text, tabular data, forms from data images, and so on and so forth. Okay, so there's a lab one, extracting text from web pages and images. What time is it? It's almost 7:48. So let me show you for a minute that how the lab looks like in your so that if you want, you can practice something. So for example, if you click on this lab 3.1, extracting text from the web, it will take actually a few minutes because it will have to start the SageMaker, I think. Let's see what it does. Yeah, it will start the SageMaker. Yep. So again, it will take a few minutes. But again, just like yesterday, it will have all the instruction, all the code inside, so you can just follow those and execute the code and try to understand it. And then let me start the lab, and then we can continue with our presentation, and then we will come back when the lab is ready. Okay. So while the lab is being, because what is it doing in the lab? That it will give you 3 hours, but you don't need 3 hours for the lab. Is creating a temporary account for me, because I'm the user and then it will log me in into AWS with that account and give me access so that I can execute. So it's creating a whole environment for me. That's why it takes few minutes. All right. So over here, uh, next step is pre-processing the text. Once you have extracted the text, then you have to process it. So what kind of processing? You have to do some cleaning up work. So you remove the leading spaces. White space means that when you print on the paper, it's white. That's why it's called white space, blank, basically blanks. And then trailing and leading, meaning before the words or after the words, leading or trailing white spaces. You can change, normalize the text to all lowercase usually. You can do all uppercase also if you want. Removing the HTML tags because they are not they are just to make the text look beautiful on a web page. Converting, that's why it's called markup. That's the markup thing which marks up the simple text into beautiful looking sophisticated text. Converting the numerical values to text representations. uh, Removing punctuations and reformatting text. These are the common cleanup tasks for text. Then you do the tokenization, which is a process that splits the text and document into small parts by using white spaces or other punctuation marks. For example, over here is tokenizing it by space. So I and there's space, so this I is one token. Then DON apostrophe T space, so this DON apostrophe T is another token. Then like another token, and X another token, and period another token. So that's why it converted this sentence into these 1, 2, 3, 4, 5, 6 tokens. Okay. And it also actually tokenized on the single code. So that's why DON and T. So these tokens now will be used in the next step in the pipeline. So once you have tokenized it, then you have to remove those stop words. The stop words are the words that are very common. They appear very frequently in text, but they don't contribute much to the overall meaning. So that's why they are just basically for human. When we're talking, we need to stop. In the middle, at least give us some pause. So that's why those words in English language, the common stop words are like like these articles, but the a, these, and then some these characters like so, is, it, at. These are very commonly occurring, so they really do not add much value in an NLP project. So that's why we call them stop words, and we want to remove them. So, for example, the original sentence which you read is there is a tree near the house. If you remove these stop words like is, a, the only thing you're left with, and even there, you're only left with tree near house. And if you if you remember, if you recall, children like that. So we as human also start talking like this without the stop words. But it doesn't sound good. So as we grow up and we just become more sophisticated, we start adding these stop words. So you can see that NLP is going back to that childish talk basically. And then you find the roots. So the set of rules to slice a string to a substring. Substring is a part of the string. Substring usually refers to a more general meaning. The goal is to remove the word affixes, suffixes or usually, or even prefixes, like ending at dash s for making them plurals, or es, or ing, or ed. So for example, the playing, played, and plays, all of them, they're coming from the root word play. Now, one issue is that stemming doesn't usually work with irregular forms of verb. For example, teach, and the past tense is taught, or bring or brought. So in that case, you have to do a little more, sophisticated programming. But stemming usually doesn't work there. Then you lemmatized it, so which is similar to stemming but more advanced because it uses a lookup dictionary. So it handles more situations and usually works better than stemming to map a word back to its stem form. So over here it can handle these irregular verb forms. Okay, so for best result, provide the correct word position and tags like adjective, noun, verb, part of speech. Okay, so lemmatization is a more complex method and it usually works better than stemming to map a word to its stem form. This is called mapping, that you are mapping these words to is their root. Okay. So for example, consider the following example. Original sentence was the children are playing outside. The weather was better yesterday. So if you done the stemming, it will say the children are says playing to play. Weather was better yesterday. If you use some more advanced lemmatization, it can be the children be play outside, the weather be good. Okay, so it will convert into. I mean, it looks sounds weird, but actually is better for analyzing the text in English language. So AWS, and Glue, Data Glue has all these services. These are called managed services. It can do the text cleanup, stop word removal, tokenization, and stemming. And then SageMaker Data Wrangler has even more. It can tokenize, stemming, vectorization, and you can write your own custom scripts for lemmatization. Okay, so pre-processing tasks for any natural language processing project are like text cleanup, tokenization, stop word removal, stemming, and lemmatization. Okay, let's look at our lab is ready. So we can close this. And then as I told you that once the lab is ready, it's been 6 minutes. So you click on this AWS button and it will start the console from where you can access your environment. And then over here, as I said that, either in other courses, actually, usually what I say that you take this out of that window over there and put it on the side by side. So this way you can have see the instructions on one side and then your console on the other side. So you follow the instructions and you read the instruction and you execute them here. So for example, say task number one is that you open the SageMaker. So step number 5 is that this was, by the way, step number 4, arrange the AWS management console. So step number 5 under task 1 is to on the console services choose as SageMaker. So you over here or you search it over here, just type Sage and then run Amazon SageMaker. Click on choose or click on Amazon SageMaker. Okay, when they say choose, it means click on it. And then from the navigation bar on the left, expand the notebook, but it's already expanded. So just click on notebook. And then look at the instances, notebook instances. And this is the instance. So it says that look for this instance starting with the CFNN. Okay. Go to the end of the row, scroll to the right, and then click on this link. They are either you can open it in Jupyter Notebook or Jupyter Lab Notebook. So click. They are saying open it in Jupyter Lab Notebook. So click on open this notebook in Jupyter Lab. Click on this one, and will again take it will start to open it. And then once your notebook is open, so number 7, then your next task is to follow the instruction in that notebook. Okay, so let it open it. It says open. So go to this on the left in the environment. Now we are in the Jupyter Lab environment. go to the file browser on the left navigation and locate the English US, this first one folder. Double click on it. It has a file, a Jupyter notebook called lab-3-1.ipynb. ipynb are the file for interactive Python notebook. So double click on this one and it will open up your notebook. And then, by choosing it and follow instruction, and all you have to do now, you can maximize this one. Now all you have to do is follow the instruction in this notebook. So it will tell you, what is it doing? Is basically doing is, extracting data. So what it does actually, I'm not going to execute it because it will take a few minutes. Because I have to import these libraries, install these things, and so on and so forth. So let's see, it's reading it from this Amazon website. They have a see this HTTPS. This is actually, if you want, you can open this in a tab, the new tab. You can open this web page. So this is a website, AWS machine learning blog. Okay. So what this thing is doing is that it is loading it into using the beautiful soup library, using the HTML parser, and then it's extracting, it's doing a lot of things from there, is from this article, and then it's just extracting the data from there. So, and it's also extract the text from images also. Okay. So this is, for example, and so the Amazon was founded in July 5th, 1994. Okay, and then it will extract the text from there. It will has an example of extracting the text from a form. Okay, and then so you can follow these instructions step by step. As I told you that in notebook, if you click on the cell, so this is the active cell with the blue bar, and then right now this blank means it has not been executed. So I will not execute this one because it will take several minutes, but I can execute this one. So how do you execute it? Either, in this cell, when this cell is active, you press Control Enter or Shift Enter. If you press Control Enter, it will execute the code in this, it's called a cell on the Jupyter notebook. So it can have multiple lines of code. It can have the whole script. It will execute the whole thing and the output will be below that. And then it will give a number, sequence number. So if I press Control Enter, so asterisk means there's the code on this cell is being executed right now. It's importing this beautiful soap. No, from the beautiful soap library, it's importing this library called or this module called BS4. And from there, it also import another library called requests. Okay, so number one. So this is the first code I executed, right? This is because I did not execute this one. And then, if I can press down arrow key. So this is actually a markup. This is a markdown language. So this is some just note. It's not. And if I go further down, it's also a markdown. And this one is a code. So it's showing you that this is a code. This is a Python 3 code. Okay, so when I'm here, I can press Control Enter or Shift Enter. So it will execute this one and it's giving me the status 200, which means okay, it was able to extract, read the page, the whole website, this website, it was able to read it, okay, into and store into the variable object called page. And now it says load the content from the page into a soup object. Soup, so soup, I'm calling it soup, calling beautiful soup function, give it the page contents, and then I say parse it using the HTML parser. So it will try to parse it using the HTML parser. Okay. And then, I say, okay, the content might be lengthy. To move to the next task, scroll down in this notebook. Um, if you want to see it, it will prettify it. So meaning that it basically, this is the code, HTML code behind this page. Okay, as you can see, it's I think probably it's thousands of lines long. Okay. So, and then the element can be accessed using dot notation. So you can you can you can read that it tells you before the command that what this command is going to do. So take your time. execute it, and then so to understand it what is doing. I will not gonna do it the whole thing because it will take too much time. We don't have much time. We are already 1 hour is gone. All right. So this is what we did in lab 1. In lab 2, we do some more. So these are called guided lab because they give you step-by-step instructions. Okay, we do the vectorization. So what is a vectorization? Vectorization means that you store the data in a column or in an array. In programming languages, we call them array. In mathematics, we call them a vector. Okay, if you remember, probably if you have taken the advanced pre-calculus, or you know about vectors. So it's the same mathematical concept because and the foundation is the mathematics, of course. Okay, let me stop the lab. So it's always a good idea that when you're not using the lab, you can always end it. Okay, so yeah, close this page, and then over here, um, yeah, just end the lab. Okay. I mean, it will end after 2 hours and 46 minutes anyway. But if you're not using it, no sense in wasting the resources because this actually has dedicated some servers for you in a data center near you, somewhere in Northern Virginia. I think it was in Northern Virginia region. So it's always a good idea to release the resources. So okay. All right. So one way of vectorizing the text is called BOW, bag of words. So this method converts a text data into numbers. Now, does this conversion by creating a vocabulary from the words in all the documents, calculating the occurrences of the words, that whether the word is present in a document or not, how many times does it happens, and then the what counts, how many words are there, and how many time each word occurs. All right, and then there's a problem called out of vocabulary problem. We'll talk about it. Okay, so binary means, for example, you have this document. Every sentence actually is considered a document. Okay, so over here, this is a sentence called "it is a dog." Period. So of course, so in all the documents, it found all these unique words: a, cat, dog, is, it, my, not, old, and wolf. And then it's showing you a binary flag, whether in this document it is a dog. Does this a happens? Yes, a occurs, right? So that's why it's 1. Now, does this document or this sentence, does it have a word cat? No, so that's why it's 0. It has a dog? Yes, so it's 1, and so on and so forth. So this is called vectorization, and it's a matrix two-dimension table. Okay, and then it will give you the count out that this the word a occurs 1 time in this sentence or document, does not occur or occur in this document, and it occurs 2 times in this document. It is not a dog, it is a wolf. Okay, so it's also keeping track of the counts. Then it creates what we call a term frequency, TF, increases the weight for common words in a document. So how do you calculate the TF? The term frequency of using the term and the documents is the number of times the term occurs or the word occurs. So term is another word for a word. Okay. So meaning how many times a word occurs in the document or sentence divided by total number of terms in the document. So for example, over here, because there are 4 words and A occurs 1 time, so 1 out of 4 is 25%. Okay, and then cat does not occur, so its occurrence is term frequency is 0. Similarly, every this is also 25%. So each word is only occurs 1, so it's the frequency is the TF term frequency is 25%, 25%, 25% for the words which occur in this document. Okay, look over here in this example. Because the word A occurs 2 times out of how many? 1, 2, 3, 4, 5, 6, 7, 8, 9 words. So 2 out of 9 is about 22%. Okay, and then 1 out of 9 is 0.11, 11%. So that's how it calculated the term frequency. Then it does the inverse document frequency, which decreases the weights for commonly used words. Because the more the word, the commonly used words, they basically lose their importance. The more commonly a word occurs, the less important it becomes. So that's why we call inverse document frequency, and increases the weights for rare words that are in the vocabulary. So this is the mathematical formula to calculate the IDF of a word or term. Okay, the number of documents, how many documents are there, divided by the number of documents containing a term plus one, and then you take the log of that quotient and then add one to it. So for example, for the IDF of the cat, word cat is 1.18. Why? Because it happens in three documents. I mean, you have three documents. It doesn't happen in three documents, but you have three documents, and it happens. It occurs in only one document, right? My no in yeah, it's only happens in one document. So so 3 divided by number of document divided by number of document containing the term actually is 1 plus 1 2. So 3 over 2. You take the log of that and add 1 to it. So it's become 1.18. Okay. Then you create, this is just one technique. This is called TF-IDF, term frequency inverse term document frequency. Yeah, please mute yourself if you're not talking. Okay. So so this TF-IDF combines the term frequency and the inverse document frequency by multiplying them actually, and then it gives you this TF-IDF. That's one technique. I mean, this is a very old technique actually, and I think we are using it since like 1960s. Okay, so a newer technique, more sophisticated one, is called n-gram. So an n-gram is a sequence of n tokens from a given sample of text or speech. So, for example, you have this sentence, it is not a dog, it is a wolf. So unigram or 1 gram will be each word separately. 2 grams or bigram will be combining two words, like it is, these two words combine will become it is. Then the next two word is not, another bigram, and then not a, then a dog, then dog, it, and so on and so forth. This is called bigram. And you can go up to as many as you want, 3 grams, 4 grams, 5 grams, yeah. So there's another technique which can help you in identifying. That's how actually ChatGPT and all these models, that's how they can. I mean, this is amazing. It looks stupid. It looks very simple and useless, but actually it's a very powerful technique which, if you can go up to the hundreds or thousands of grams, that's how it generates all your blogs and things like that, chatting chatbots, and even chat gpt. They use some more advanced, of course, algorithm, but this is the basis, very basic. Another is called word vectors, or word to, because the problem, those are so far what we have talked about, the n-grams and there's a TF-IDF and all those, these are the bag of words techniques. So the problem is these model is that you don't get any information about the meaning or the context of the words. Okay. So therefore, this BOW or bag of word does not capture the relationships between words. For example, the contextual, that which words are close to which. So this relationship could be as simple as, for example, the cat, dog, and wolf, which often refer to animals in the context of pets, for example. Some people do have actually pet wolves. Now, word vectors represent words as multi-dimensional and continuous floating point numbers. So semantically, similar words are mapped to nearby points in the vector. Therefore, words such as cat, dog, and wolf should be close together, but light bulb should be distant. For example, over here. So this is creating a 2 dimension. So that was a 1 dimensional thing, right? So far, bag of word. Now we are going to do 2 dimensions. So over here, you have the space. So as you can see, for example, over here, husband, wife, daughter, they are close to each other because they belong to one family. family, right? And then women also, of course, has relationship with the family, and if men would be there, it will also be there. And there is comedy, funny jokes, laugh. These are like the genre of some whatever the context is, or television shows, for example, or series episodes and television show. So this word vectors or word to vec algorithm, it learns an embedding vector for each word, and then it produces hundreds of dimensions. Actually, I mean, yeah, we are showing over here only two dimension, but it can be hundreds or thousands of dimensions depending upon the number of words. Words with similar semantics are grouped close together. Now we cannot, and that's where the power of mathematics comes into play, that we can only show two dimension on a screen or a piece of paper, but mathematically we can have as many dimensions as we want. So internally it stores it into thousands of dimensions, and now actually we are talking about billions. Okay, like the chat GPT, and that's how because for each dimension it calculates the distance, that how far that word is from other words in that dimension. So words with similar semantics are grouped close together, like over here is showing you. You can use the pre-trained models also, and that's what the chat GPT and all these and generative AI model use. Or vectors can be visualized by using t-distributed stochastic neighbor embedding also. This is TSNE. These are statistical functions, okay? Now, words that are not in the corpus or in the body of the dictionary, or the corpus is the body of the words, documents, it returns zeros. And the vectors are used for downstream NLP tasks, meaning that downstream means that after this task, there will be tasks down the line, down the stream. So down the pipeline. So those tasks will use these vectors. So there's another technique in word2vec is called continuous bag of words and skipgram. So this CBOW generate the center word from context words. So for example, it's found that the loves is a center word, and the man loves his son. So all these other four words actually they are basically center around this keyword context. This is giving you the context. The skipgram, a word can be used to generate the words that surround it. So if that's how chat GPT or all these chatbot they generate that, they look at these words, and then this thing they find out that what would be a good word to insert in the middle, around which these words can be combined. So based on the model which you train, the data which you train it on, it can find the word, for example, love or hate or help or whatever it is, depending upon the context. So that's how it can generate. That's why we call it artificial intelligence, but actually it's all mathematics behind the scene. So Amazon SageMaker has another tool in this environment is called Blazing Text, which is a highly optimized implementation of word2vec algorithm. It accelerated training on GPUs, because why we need GPUs for them? Because we can have billions of words. So these models have been trained on billions and billions of documents. So they will have trillions of words actually. And it uses highly optimized CUDA kernels. CUDA is basically this is the GPU language which NVIDIA. That's why NVIDIA became the $3 trillion company, because even though they started as a graphical processing for video games, but it turned out that these parallel processing, because that's the concept, that they can process in parallel, simpler processors, but they can process the data in parallel, and it's ideal for matrix manipulation. And most of the artificial intelligence algorithm, they are matrix based, multi-dimensional actually. Matrix is only two dimensional, but so as you can see, as we talk about that, the word2vec can be thousands of dimensions or millions of dimensions. So GPUs, that's why GPUs are in such high demand. So they have a highly optimized CUDA kernel or backend on these GPUs, and that's why they are actually on back order. NVIDIA has back order from the big companies, for all the companies actually, for their GPUs. That's why NVIDIA stock is going skyrocketing. So provides the so this SageMaker blazing text provides the continuous backward and skipgram training architectures, and you can the output, which is it gives the vectors in a text format, are compatible with these some other libraries, generative simulator and spacey, which is some libraries, and subwords can generate vectors for out of vocabulary words and use for classification also. Now, these are some advanced techniques, of course, but these are the basis of NLP. So this text vectorization with some managed services means that these in on AWS or on cloud in general, everything is web service. We just call it service. Now, there are three basic models, so I don't want to go into the detail of the cloud architecture, but either you can just use it as a what we call infrastructure as a service, IaaS, where it's just like you have your own infrastructure, your own hardware, but instead of owning it, you just renting it, or for a few minutes or a few hours or even few seconds from AWS or a cloud provider. That's called infrastructure as a service. So you are responsible for it. They just give you the hardware. Like for example, when I start the lab, that's what I am doing. I am generating, I'm basically renting or leasing some hardware from AWS, but I am responsible for managing it. So the lab script is managing it. Now, in the managed service, we don't worry about the hardware. We just say, hey, I need this service, and it goes and automatically provisions the hardware for me and manages it for me. This is called platform as a service, PaaS, and the highest level is called SaaS, software as a service. In software as a service, I just say, hey, I just want this piece of application or software, and it will automatically do everything for you. That's the highest level of abstraction. The highest level of that you have you don't even know what hardware is being used, but you don't care about it. You just care about your business problem. So these managed services, meaning they are usually platform as a service, meaning that they are managed automatically depending upon what service you take. So the glue data glue is does not allow give you a text vectorization, but SageMaker Data Wrangler does. It has a count vectorizer, numerical and binary, and a TF IDF, and then generates columns or a matrix. Okay. So in this lab 3, in this module, you will have this encoding and vectorizing the text. All right. So we talked about a lot of these techniques: bag of words, term frequency, inverse document frequency, term frequency, inverse document frequency, n-grams, word vectors, continuous bag of words, skipgram, blazing text, data wrangler. All right, so let's go into some more advanced processing because this is not enough. Human languages are much more complex. So we need to do some syntactical analysis and semantic analysis. Syntactic means related to the syntax of the language, and semantic is basically more context oriented. So these analyses look at the word order, their meaning in the context, the retaining stop words, morphology of the words, parts of speech in a sentence. So for example, consider this Amazon Alexa. So when you say, Alexa, who won the ping pong in 2018? So, it trying to understand, okay, 2018, you are referring to an year time frame. And then it creates this, the relationship, the ping pong in, so it's creating a relationship. Okay, so this is called syntactical and semantic analysis. So, so Alexa must understand the structure of the question to be able to answer it. So syntax, right? So the phrase ping pong relates to an event, which what happened in 2018, which is a time frame. So the event and the time frame, have a relationship between them. And then it has to assign the part of speech categories also. that okay, this Alexa, this is basically a noun, then pronoun who, and the verb, so this is basically verb, noun, adjective, adverb, pronoun, preposition. This is the English language. They have eight um, parts of speech, I think, if I remember correct. One, two, three, four, five, six, seven, eight. Yes. And then they added two more, numerical and determiner. Okay. So, so for example, 2018 is numerical, right? And this determiner is create the relationship. This the and the in, these are determining the relationship. That's why they are called determiner. Then it does the constituency parsing. Identify the common grammatical patterns, noun phrases, verb phrases, prepositional phrases, and so on and so forth. So that's where the whole the what we call the language, like not Chomsky. Noam Chomsky, I think he's a famous what do you call linguist what work in that arena. So when the parts of speech have been tagged, identified, the noun, verb, and preposition phrase are detected, then you can understand the meaning of the text. Typically, English has a subject, verb, object a kind of structure or order. The basic idea is that a sentence is about something, subject, and it usually involves, subject and a verb and an object. Most sentences are more complex in the real life, but the same parsing rules can be applied. So, for example, in this example, when you do this, what we call subject verb object kind of parsing, who is the subject? Okay, that who is the subject of this sentence? Alexa deduces that the who must be a table tennis or ping pong team based on the object. Or what is the object? The ping pong. Okay, and then the verb is one. And then so this is how the NLP parsing will try to understand it. So relative clause modifier, nominal subject, direct object, object of preposition, and prepositional modifier. So this is how it has to parse this sentence. And then it has to do the co-reference relation, which is to identify, mentions in text that refer to the same underlying object. So this co-reference can be anaphoric, which refers to the previous text, or it could be cataphoric, which refers to the future text. Now, it is important for our systems and chatbots and virtual assistant, for example, Alexa, to understand these what he, she, or it refers to. Okay, for example, Diego went for a motorcycle ride. So he refers to Diego. Said it refers to motorcycle, or his whole ride, actually, motorcycle ride. So so our language processor or also need to understand that. Okay, catastrophic refers to the future text. Every time she goes for a motorcycle ride, Akua has a smile on her face. So here, she refers to the future. That's why it's catastrophic. This is anaerophic because it refers to the previous text, but catastrophic refers to the future text. So she in this sentence refers to Aqua in the next part of this or the phrase. Okay. So this understanding the meaning of sentences, this part of speech tagging, constituency parsing, dependency parsing, co-reference resolution. So these are, you need for these application like information retrieval from the text, chatbots, virtual assistant, and so on and so forth. Then once you have that this parsing, then you store and visualize this unstructured. I mean, that is another thing you need to do actually. So you have these, structured data and unstructured data. Okay, so structured data is defined in what we call a schema. The schema or structure is defined. So, for example, an employee record, where defined set of field name and contact information, and name can be subdivided into the first name and family name, last name, and contact information can contain the phone numbers, which are integers, and it could contain email address, which will be a text and address, and so on and so forth. Now, unstructured data does not follow a schema, set schema. For example, over here, in the blog post, the title, could be any number of words or any number, date, and some posts may have that date, some may not have date, some have text, some may not have text, and so on and so forth. So these are some AWS services for storing. S3, as I told you, simple storage service is the most common. It gives you virtually unlimited object storage. Is called an object level storage. Okay, so every document is basically an object. So it's most common storage service for machine learning and is suitable for both structured as well as unstructured data. Then they have some more optimized services like Elasticsearch, or now it's called OpenSearch actually. This is old because Elasticsearch was an open source project, and Amazon bought it and they call it OpenSearch now. Not bought it actually, but because it was open source, so they took it and then they modified it. So this is a managed service for building search-based application. It works with another visualization service called Kibana for data visualization. Automated data loading integrates with language plugins also for different languages. And then more modern database is Amazon Neptune, which is a what we call a graph database. Okay, supports common graph models, automated backup to S3, and provides RAD replicas for high performance. So these are advanced services which, but you will most likely just start with S3, and most of the time just S3 is enough. Now, for natural language processing, this S3, buckets or folders are used to store the machine learning artifacts like all the raw data, the process data, your data models. It's a commonly used data storage service, very cheap, is used for NLP problems that do not require high-scale searches or learning knowledge searches. For that one, then we will need these other services like Elastic OpenSearch or Neptune, and there are some more. Okay, so this OpenSearch or Elasticsearch use cases, when you should consider using it to build visualization data based on complex searches of text data, for like GPS applications and self-driven cars, for those kind of application. Access time series views of text, track the customer reviews over time or the car movement, for example, view relationships between documents in a collection, perform complex search integration with NLP interfaces. For Neptune, this is, a mathematical graph. It's not a numerical pictorial graph. Actually, when they call it a graph database, it's a mathematical graph. A mathematical graph has a lot of properties. It has a whole what we call uh, graph theory behind it. So navigation tool for discovery of scientific research papers, for recommendation engines, visual representation of data, detecting fraudulent transaction, network traffic analysis and planning, and so on and so forth. All right. So basically you have to understand the structured data, which conforms to a specific structure or schema, predetermined, prefixed set of fields, set data types for each field, and length, is supported by traditional database management systems, especially relational database management systems. That's why you use the SQL language for querying them. Unstructured data is is like it's also called no SQL data. Databases, they don't have a predetermined spec schema, and then they are also semi-structured like XML, JSON, and EML. All right. So that was about this. As you can see, it's a lot of information here. So, this module has 3 labs, hands-on labs, which you can explore further. Next module is about sentiment analysis. We only left how much? About half an hour, less than half an hour. So let's go into this information extraction because I think that will be more relevant to your hackathon. So let's go into this module 5, information extraction, so that you may understand some of the things. So type of information extraction, and then there's a lab also. There are two labs actually. All right. So this one has 47 slides. So what is information extraction? So information extraction refers to the NLP task of extracting relevant information from the text. Now, this information extraction or IE can be a challenge with unstructured data. Okay. So for example, if a data is stored in a database, then it can be very simple because column names, the headings, the name, address, for example, the person name, they can give you the label. With text, the data is unstructured, so you need different ways to extract that information from. So a collection of, for example, movie reviews written by both professional movie reviewers and the public is a good example of unstructured data. So data is unstructured because there is no standard set of fields or columns with a set length or data type. And there are no predetermined relationship between the individual data objects. So this lack of structure makes it sort of a data set an ideal candidate for information extraction with machine learning. Okay. So, for example, here, like for digital assistant queries, you can ask, for example, in today's system, for example, where is the nearest coffee shop? And this where, it tells you that you have to understand, you have to make your digital assistant understand that where is basically meaning it needs the address nearest from the current location of the asker, or whoever is asking, and then the target location. So another example application of information extraction is identifying common themes in reviews, for example. And this is what you will be doing also, like for example, analyzing the documents about, for example, Muslim or Islam. So you will read reviews that mention some of the keywords. So over here for the product reviews, you will be looking for these kind of words or phrases. Okay. Easy to install, video card, power supply, liquid cooling, overclocking. So this is like for about related to CPUs or computers. Then tagging news is another application of information extraction. So extracting names and some common trends, from the news events and location from news article can help identify the trends or highlight important entities within them. These are called entities. Then another application of information extraction is in the finance industry, of course, extracting the financial data. For example, Amazon, this is an article, okay? So Amazon, NASDAQ ticker symbol AMZN, and Whole Food Market Incorporated, this is a NASDAQ ticker symbol WFM, today announced. And so over here, it has to have some like known entity as business, person, the relationship, and the numerical data. So it has all these things. Okay, so it has to highlight like green, like these are the known entities: Amazon, Whole Food, Whole Food Market, and Amazon. These are the business entities. Then the known entity, for example, Jeff Bezos is a known person. Then the relationship, founder and CEO, and the numerical data like $42 per share, and then this $13.7 billion. Um, so, for example, extracting events, example event with basic information. Okay, so these are like dates, some events, time, locations. So information extraction, they are very important for digital assistants, identifying common phrases or themes in reviews, tagging news, identifying financial data, extracting event. So you should think about it. How can you tag different articles, whether they are, anti-Islamic or coming from the negative review, or trying to spread the misinformation about Islam and things like that. So you have to think about those kind of lines. So what are some of the different types of information extractions? These are the basic 5 types of information extraction. Key phrase extraction, sorry, which is extracting useful words or phrases from the text, key phrases. Then name NER, or named entity recognition. NER means named entity recognition, identifies entities such as pupil names, locations, organizations, dates, product names. In your case, you will identify the, for example, Islamic names, Islamic, theological concepts, and those, so on and so forth. Then named entity disambiguation. This So that was named entity recognition, and this is disambiguation. So this is about uniquely identifying entities in a text. To disambiguate, meaning that there could be ambiguous entities, synonyms, or something which you have to identify. And then you have to extract the relationship between those entities, and then the events. Okay. So key phrase extraction, the first thing, key phrase extraction extracts useful words and phrases from text to capture the general intent. Okay, in your case, for example, it might be that, anti-Islam, inflammatory, hate speech, or bias and things like that. Words is generally unsupervised learning. Words are nodes in a weighted graph. This is again the graph theory concepts. Weight indicates the importance of a key phrase and how well are the nodes connected with the rest of the the words in the document. The top X nodes are written then. Okay, the key phrase. And then you determine the word significance. The using the TF-IDF, or another is called keyword, are used to determine. Now, keyword is a minimal keyword extraction technique that uses bidirectional encoder representation from transformers or BERT embeddings. So keyword uses these embeddings to create keywords and key phrases. So these are algorithm already built in. So Amazon Comprehend has an API for performing these KPEs. Amazon Comprehend is a service which provides you this API, means the function calls, which you can call the functions, they already written for you, and you can use them in your scripts. Then the third type is in determining the named entity recognition. So NER, or named entity recognition, is the NLP task of identifying the entities such as the names, locations, organization, dates, and product names. So this NER is often needed for downstream tasks such as event or relation extraction and translation. Spacy and BERT provide tools for extracting and visualizing the named entities. So again, Amazon Comprehend provides API actions for entity recognition, okay, to find insights and relationships. And then Spacy also has a library, excellent set of tools for extracting and visualizing named entities. Okay. Then for disambiguation, named entity disambiguation, or NED, is the NLP task of uniquely identifying entities. For example, Ford forwarded the Ford in the Ford. Now over here, their Ford happened 4 times, but each one of them has a meaning in the context. This Ford is the name of the person. Forded means founded. So this Ford is refers to the company, and then in the Ford, whatever that could be, depending upon the context. So you have to disambiguate this word 4 times. Okay, so this could be the Ford family. Then you have to extract the relationship, which is the NLP task that identifies relations between entities. Okay, so how do you extract that Jeff Bezos is the chief executive officer of Amazon from this sentence? Okay. Event extraction is the process of identifying and extracting knowledge about events in the text data. Okay, so this you have to identify the events and dates. So these are the five, basically types of information extraction: key phrase extraction, name entity recognition, name entity disambiguation, relationship extraction, and event extraction. So how do you implement it with the Amazon Comprehend service? It uses pre-trained models to do this. It can detect entities, detect events, detect key phrases, detect personally identifiable information, PII, which you have to protect or anonymize because of the laws, HIPAA laws, for example, and analyze syntax. So this is a function or an API call which starts an asynchronous job, meaning that this job does not stop your script from running. It just does it on the side. Input and output to Amazon's S3, and it uses the UTF-8 coding with a maximum size of 102,400 bytes. So you can give it, this is called JSON, for this is a JSON format. This is a JSON object, JavaScript object notation object in curly braces, and it has key value pairs. This is the key file value small dog. Entity is a list. The square brackets meaning is a list. List contains multiple sets of key value pairs separated by commas. This is called a JSON format. Okay. So you can use this start entities detection job call function, and then you can use function for listing, for example, for and then describing. When the job is completed, the results are output or set to sent to an S3 bucket that you specified. So for example, over here, it's only you're only giving it the data, but you will have to also the type of, for example, over here could be person, it could be location, it could be organization, commercial item, event, date, quantity, title, or other. Okay, so Amazon Comprehend can implement custom entity recognition also, either through annotations or entity lists. So you can train and a custom entity recognizer rather than just limiting you to the whatever already there. So if you have sufficient data to train effectively, you can identify almost any entity type, which is basically a supervised learning because you will be labeling the data. So you can provide data to Amazon Comprehend in two ways, either through annotations, which provides the location of your entities in a large number of documents so that Amazon Comprehend can train on both the entity and its context. And in the entity list is provides only a limited context and uses only a specific entities list so that Amazon Comprehend can train to identify the custom entity. Okay, so you have to think about it, which one you will be use, and then to see how to use them, you can do the lab to help you in understanding. So annotation, train 25 entity types per model. Use training data with an annotation file. So this is, excuse me. So this is the training data in the file called documents.txt. And this is a document. Anna Carolina Silva is an engineer in the high-tech industry. John Doe has been an engineer for 14 years. Georgie Souza is a judge on the Washington Supreme Court. Our latest new employee, Smith, has been a manager in the industry for 4 years. And then this is how you provide the annotations. Line number 0, that is whatever, type is an engineer. Starting at position, ending, so this engineer starts from position 0, Anna Carolina Silva. So this is at 18 characters or 19 characters. 3, 1, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 characters, 0 through 18. Okay. So that's why it's called supervised learning, because you have to provide it all these lines, these how to label it. There's a service called SageMaker Ground Truth. Okay, because if you have a large annotated training document, it's a very complex process, time consuming. So you can use the SageMaker ground truth to label the data set that is required to train and comprehend custom entity recognizer. The ground truth provide built-in labeling workflows that take human labelers step by step through the tasks. Okay, so what you do, this is the process. You upload a text file, a set of text files to Amazon S3 bucket. Then then create a private work team and an NER labeling job in the ground truth service. Okay, so you store them in the S3 and then you create a team. Then the private work team labels all of the text documents. Okay. Then on completion, the ground truth creates an augmented manifest named manifest over here or manifest, and then AWS Lambda function then passes the output manifest to create the annotation and document in CSV format. And then the comprehend console launches a custom NER training job. So, oh, sorry. So this is something you will have to implement, but you cannot do it, of course, on one day. But you will have to understand the workflow. Now, the other way of providing the entity list, okay, that one, yeah, this one. So you supply a CSV file, comma separate value file with only the two columns, which contain text and type, text and type. Okay, so it will automatically label it. You provide a data, and then you provide a list. The customer defined type. An entity type must be an uppercase underscore separated. You know, string such as manager or senior manager. So over here in the type, you cannot have a space. You have to have underscores. You can train up to 25 entity types per model. So the following lines are an example of a training file, and then it can understand those entities and label them. Now, Spacey is another way of extracting information, which is a Python library, which provides many tools for natural language processing. It includes a statistical entity recognition system, which assigns labels to contiguous spans of tokens. So, but this will be a little more complicated. Um, so, for example, over here, you import the specie module library, then you create, you give it, create a, actually load this file, and then, you give it some context, and then it automatically start doing this for you. Okay, so in this library, in this module, sorry, lab, they give you some, but how you can do it in the, it's almost time. So, and then there are two labs in this one, in this module. So let's go and see one of the labs. For example, what do they give you in the lab? So if you go to this lab 5.1, you again access the SageMaker, and actually all the instructions are given in the notebook. So you just start it and then just follow the. Let me start this lab and see what it does. Okay. And then in the next lab, I think, what do you do over the next lab? The second lab is about working with the entities. So this gives you 5 hours because this will be a long lab, but it will be good practice for anybody who's serious. And then the next lab, actually you can start, I think, up to 2 labs together. In the working with entities lab, this is the beauty of this course, that you don't have to worry about the cost or anything else, So in this lab, you will use Amazon Comprehend to extract key phrases and entities from the CMU movie summary corpus or body of document. You will then feed the result into an Amazon, it also gives you 5 hours, into an Amazon Elasticsearch or OpenSearch cluster and build a Kibana dashboard to view and filter result. You will also look at building word clouds and using n-grams to extract key phrases. So this is the movie summary corpus it goes into. It is the Carnegie Mellon University. They have this data corpus. So this lab, you will be able to implement key phrase extraction, implement entity extraction, store text in an Amazon Elasticsearch or OpenSearch service cluster, build a dashboard in Kibana Visualizer. Okay, so it also gives you just, yeah, and all the instruction in the lab. So we have few minutes left. So let's see if the lab comes back. Okay, David Kadir. Yeah, I will add you so that you can access this. Are you still there, David Kabir? No, I think you're not there anymore. But anyway, okay. He sent me an email. Key assignments. It takes you to module, so you have to go to back to the module. And module 5. Let's go back to slab 1 and see if it is ready. I think it's ready. So go to the AWS. Oh, because I started the second lab, so that's why it actually it's a different every time you start a lab, it's a different. Yes, I forgot. So that's why it's invalidated the credential for that lab. So I think I'll have to do it with this lab. Let's see. No. Hmm. So let's go back to lab 5.1 and see if it should be ready actually. Because for every lab is a different account. That's the problem. Okay, so we are here. Let's go to SageMaker. Let's see if our lab is ready. Notebooks. Yeah. This is this is pending. It's not ready yet. Okay. No, no, it's ready. Okay. So open it in Jupyter Lab. Okay, go here. This is our notebook. Okay, Python 3 is fine. So yeah, it writing documents to S3, so it create a bucket. Okay, asynchronous event detection. So yeah, it gives you the code starting an asynchronous event detection job using the software development kit. Boto 3. So it will have to import Boto 3. Yeah, Boto 3. Yeah, Boto 3 lab. Okay. Then process company press release. You can define the event types, start the Amazon comprehend job. Okay, analyze the comprehend events output, understanding the comprehend events system output, stable data, creating a more succinct representation, formatting the data, visualizing it. Yeah, so it will take some time, of course, but once you at least you implement, you determine, read through the slides, try to focus on what you want to do for the hackathon. I mean, you only have a couple of days left, but if you want, you're interested, you can still do some useful work, at least for the prototype. All right, guys. So I think that's good enough for today. Any questions or comments? Okay, well, I don't want it anymore, so I will end the lab. This lab, I don't want to. I mean, do something which is not necessary. So this is lab 5.1. We can go back to lab 5.2 and see what's going on there. Working with entities. So the next module is like about topic modeling. This is another technique. Working with different languages. This will be a good detecting and translating languages. Working with generative AI, little advanced topic. So let's look at what's going on in lab 2, 5.2. So you have to log out from the previous account and then close that, and again now log in with this new account because each lab creates its own account. SageMaker, go to your notebooks. This is our notebook. Oops, sorry, this is our notebook is already ready. So I need to open this in Jupyter Lab. Okay, in English language. This is our notebook. Open it using Python 3. So this will install the packages, reviewing the data sets, okay, normalizing the text, then start the comprehend jobs. Okay, okay. Open search cluster. Oh my God. Okay, using word clouds and n-grams. Okay. This is a big lab. Creating the Kibana dashboard. Okay, so you can see a lot of things visually. See, now it's called open search. All right, guys. Okay, I think that's all for today. So I will add, if you want to practice this, send me an email. Again, my email one last time, I will show you. It should be here, mohammedsabri01@gmail.com, with MU and muhammad@gmail.com, and I will add you to the course so that you can do these labs if you want. All right, I hope you will be excited to work on some of these things. This is really the high tech the feature. So if you want to go into this into IT, I think this is the hot field, AI, machine learning. Okay. All right, guys. So good night and the best of luck. Assalamu alaikum.